Hi, in this video we're going to take a look at some of the student examples and workbook exercise questions together. Feel free to pause the video and try them on your own and access the video should you feel stuck. We're going to take a look at this first example on the top of page 327 where we've got a pattern of toothpicks. So it's showing us a visual pattern. Figure 1, we can see that we have 4 toothpicks creating kind of a diamond shape. So I'm going to write that below, 4. Figure 2, we have 1, 2, 3, 4, 5, 6. Figure 3, we have 1, 2, 3, 4, 5, 6, 7, 8. So they're asking us in the first part to draw the next 2 figures. Personally, I'm very poor at drawing, so I don't really want to do that, but you could certainly start to draw, seeing the pattern that you would have 10 and that you would have 12. You would continue to draw, but really you should draw figure 4, figure 5, and kind of draw it all over again. I'm going to erase that. You can also begin by making a table of values. So you can see on the sidebar they do the drawing, but I'd rather make a table of values. The figure number is always your x value. And we can see that the figure number is going from figure 1 to figure 2 to figure 3, and we know the next one is going to be figure 4. So we're going to show that 1, 2, 3, and we can even put the next one in, even though we may not have it visually. The number of toothpicks or sticks that we have 4 in figure 1, 6 in figure 2, 8 in figure 3, and we can predict what's going to happen next. We know we're going to have 10 because we have a +2 pattern. So our brain is wired pretty well to notice patterns for numbers. We've got a +1 pattern for x and a +2 pattern for our toothpicks or our y. So when they ask us to write the pattern in words, we can say something like, well, for every new figure, we add 2 toothpicks. And so the way we say it or write it could be slightly different from one another, but we're all going to come to the same kind of idea for the pattern. So for each new figure, we add 2 toothpicks, or there are 2 more toothpicks. Something like that would be how I would express this pattern in words. For C, it's asking us to write an equation that relates the number of toothpicks n, so the toothpicks is the capital N, why they choose that I don't know, to the figure number little n. Now remember, making a table of values is very, very helpful. So figure number, we will learn and through experience we'll know that that's always going to be our x value, and that's going to be, in this case, figure 1, figure 2, figure 3, figure 4. And as we established the toothpicks, we started off with 4, then we went up to 6, then we went up to 8, and then we could go up and up by 2s. So our pattern for our sticks, or capital N, or Y, that's a +2 pattern. And the pattern for figure numbers is a +1 pattern. We look at our equation. Our multiplier is our Y pattern. So we are going up by 2s. So Y is equal to 2 times x, and then we try it. I'm going to now multiply 1 times 2. That equals 2. And then I have to see, do I need to add or subtract to get to the y value? I have to add 2. I can check this with another x value, multiplying it by 2. 3 times 2 equals 6. And I see, do I need the same number to bridge? 6 up to 8 is a +2. 2 up to 4 is a +2. I know that I have a good pattern. So my bridge is going to be plus 2. I find it easy to build my equations using y is equal to mx plus or minus a number, and then I use the letters they want afterwards. That's just the way that I do it. So then I just rewrite my equation. Y is a capital N, and x is a little n. And so I'm able then to create the equation that they want using the variables that they want. But I always do that after I create from my master equation. Now that we have the equation, we had our table of values, we had our equation, now we can solve D. How many toothpicks are needed for figure 80? If we remember, our x value was the figure numbers, and the y value was the toothpicks. And so we had the equation of y is equal to 2x plus 2, or that n is equal to 2n plus 2. So now that we want to know the toothpicks, and x is equal to the figure number, now we can use this equation to solve. So figure 80 is our x, so we're solving for y. 2 times figure 80, which is our x value, plus 2, and so y is equal to 2 times 80, 160, plus 2, y is equal to 162. So we would have 162 toothpicks if we were to draw up to figure 80. Question number 2 on page 328 is one that often gives difficulty just because of the way it's laid out. So I'd like to take a look at this question and possibly question 3 and 4 as well. They're all based on this visual information. So what we have here is we have kind of a banquet set up with tables and chairs. And so we see here that in the first figure, we have 1 square and 4 triangles. So it's like a table with 4 chairs. So we can see that expressed here. And in figure 2, we have 2 squares and 6 triangles. So 2 tables and 6 chairs. So what they want us to do is they want us to fill in x1, y1, x2, y2. So in figure 3, how many squares do we see? Well, we see 1, 2, 3 squares. So I'm going to fill that in right beside the word or letter x1. And then how many triangles do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to place that in there. And then for figure 4, we have 4 squares. And even without counting triangles, although I can never stop myself from counting them, we can start to see we have a clear pattern. 4, 6, 8. We know we're going to be going up by 2 here. It's going to be 10. But just to be sure, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, absolutely. So when they give you the multiple choice question, what are the values of x1, y1, x2, y2? I write them above and then find the choice that matches. x1 is 3, y1 is 8, x2 is 4, y2 is 10. And so we find the one that has 3, 8, 4, and 10. So it's a bit of a strange question, but what we're creating here is a table of values. The figure number for figure 1 has squares, and then we have triangles based on how many squares or tables we have. So we're going to take a look at the question 3, which of the following equations represents the relationship between the figures where x is the number of squares and y is the number of triangles? The best thing to do here is to make our table of values, showing that to ourselves. X is the squares, y is the triangles, and we can see by the visual that when we have one square, we have 4 triangles. When we have 2 squares, we have 6 triangles. When we have 3 squares, we have 8 triangles. And we don't have to go any further than this. We can clearly see our patterns. For the x, we're going up by 1. For our tables, that's a +1 pattern. For our y, we're going from 4 to 6 to 8. That's a +2 pattern. Now we can create our equation using our master equation, y is equal to mx plus or minus a number. We are going to take the pattern for y as our multiplier. That's a +2. Multiply it to x. We're going to try that. We're going to multiply the x values by 2, see where we end up, and then what do we need to bridge up to our y value. We can do that for one of them. We can do that for all of them to check our bridge. But we can see that we need to go up by 2 to get back to our y number. 2 up to 4, 4 up to 6, 6 up to 8. So we have a +2 bridge. Our equation is y is equal to 2x plus 2. And we find that our solution here is B. Now you should be ready to tackle question number 4. How many triangles would there be in a figure with 15 squares? You can use your equation, use substitution to solve for what they're looking for. In this case, you're looking for triangles, so you're going to be looking for your y value. Working with patterns is a real skill, and creating an equation from a built table of values is a skill that takes a lot of practice. We'll be talking about the practice that you need to complete in order to feel confident at the start of making table of values and equations.